Yeah, so I'm really happy to have this presentation today. My name is Daniela Karthaus, and I work as innovation technology scout and optics engineer at Forvia Hella. And today I'd like to talk a little bit with you about the blockers and enablers for micro and nano optics in automotive lighting applications. So before we start, I have here just a short slide about one topic that is always to be discussed, the correct categorization of optics that we are talking about. Um, so in general, of course, we can categorize optics according to their size as macro optics, micro optics, or nano optics. So we have a millimeter range, micrometer range, or nanometer range. But we can also categorize them according to their physical principle as refractive optics, diffractive optics, and I called it quantum optics. So if anybody in the meeting has a better wording for that, please let me know. But I think it's clear what I mean with that. And in these categories, we have the different types of optics. And often we have a problem that somebody is talking about a really specific type of optics, like, for example, a binary diffractive DOE, binary diffractive optical element, but he's talking about micro optics in general. So it's a little bit difficult then to know what exactly is meant by the characteristics and the like. So it's important to be really specific here. And to let you know, today I will talk about micro optics, meaning refractive and diffractive micro optics, and nano optics, more in the region of here, diffractive optics or meta optics. And I'd like to start with general enablers that we see for micro and nano optics. For example, you see here the image where we have an aspheric lens, a macro optic, and beside we have micro Fresnel lens with the same functionality. And you can clearly see that we have a low volume, a low material consumption, we have a low weight for this component, and with that we have a lot of advantage concerning installation space when we use this type of optics here. In addition, the structures of micro and nano optics is of course really small, and with that nearly invisible. Not the structure size in general, because we always see that something is there, there's some structure on the surface or something like that, but the functionality is invisible. So when we switch on the light, we see, oh wow, this is happening, and this is really an aspect for styling for us, a great advantage here. And in addition, we have, of course, high efficiencies that can be achieved with micro and nano optics. And these are, from my perspective, exclusive characteristics for micro and nano optics compared to macro optics. And in addition, we have a wide range of functionalities. We can use them all for illumination, for imaging, and we see a lot of different potential applications like diffuser optics, as you can see it in the image here, for the flat light that I will highlight a little bit later. We can use them for beam shaping, for projection, or for headlamp systems, for compensation of aberrations, then in connection with macro optics, of course. But there are a lot of different applications that we see here. Why now we don't use them for every application I mentioned here? This is the topic of blockers, and I will come to that later on. First of all, maybe I'd like to give you a short insight about the developments at Hella concerning micro and nano optics. And I'd like to start with the Fabulous project, so I don't have to explain it anymore because it was already introduced here. And Hella is one of the use case partners in the Fabulous project, and our target is to develop freeform micro optics for headlamp applications. And you see here two examples for the different structures that we evaluated until now. And this one, for example, is generating a kind of low beam distribution. So maybe more a tendency towards a low beam distribution. We are still working on that. This was just the first step, but it's really promising. And we clearly see a potential here for refractive micro optics. Then the topic of flat light. Flat light is a technology where we want to generate really thin modules for signal and tail lighting applications. So they should have a really homogeneous appearance, and they should have a really high efficiency. And with the flat light micro MX that is shown here at the top, we achieved that. And for that, we used an optical stack with different optical layers. So in the region between 3 and 5 layers. And each layer has a different micro optic structure between in the region of several micrometers up to 100 micrometers. And with that combination, it is possible to achieve our targets here. And in addition, we have, of course, the flexibility to combine this flat light technology with other technologies like displays. And then we have a digital flat light. But to come back a little bit to micro optics, another topic for us is holography, and this is my favorite topic because I worked on this during my PhD research. And we see holograms as one example for decorative elements. This is the nature of holography, so this is of course one of the topics. And you see here in the image an example where we generated a nice 3D appearance with text and a kind of mirror surface just generated by a hologram, which is really a nice, eye catcher, let's say. But we also look for functional elements, and this is shown by the other image where we want to combine, a nice tiling with a tail lamp function, or as you see it by the schematic image here, we also look for headlamp application. And these topics are still under development on research level by my colleague, Mr. Hiller. And we are really curious about the results here because this is, of course, then really a push for the topic of holography. And one other aspect is meter optics. So as an example, I have here the topic of a meter optic projector, where we want to generate phase holograms with meter structures and use or generate really small projector systems for projection around the car, for road projection, for communication. And here also my colleague, Mr. Hiller, showed last year some results. And we were able to achieve really a high efficiency, and we have a really good visibility of our projections even at daytime. And of course, this is something, especially with look to autonomous driving, a really interesting topic here. Of course, the list is not complete. We could also talk further about diffractive optics in different applications, hybrid diffractive refractive optics. But I think as an insight for you, this is enough because otherwise I'm running out of time. And therefore, I'd like to come back to the topic of blockers. So why is this list, another reason why this list is maybe short? And the main blocker I see currently for the usage of micro and nano optics is the mismatch between LED characteristics and optics characteristics. So I just had an example with a meter optic where we used a laser diode, but typically if we have the choice between LED and laser diode, we choose LED. And therefore, we have these challenges I want to list here is the first one, the polychromatic spectrum versus wavelength selectivity. So even if we use a narrowband LED, we get trouble with dispersion, especially when we talk about diffractive optics or holograms. Then the LED chip sizes and the optic sizes. So we are getting smaller and smaller with the optics. High power LEDs for automotive are typically still in the range of square millimeter or slightly below. And the main challenge with that is related to the next point, that the emission characteristics of the LED do not match with the characteristics of the design light source. And typically we there have point or parallel light sources, and an LED is a Lambertian radiator, or if we are getting closer and closer to the LED with our micro and nano optics, we have a surface emitter. And then we get really into trouble when we design this for such ideal light sources here. And the last point is that we often have to use multiple LEDs because we have to fulfill legal requirements and the intensity of one LED is not enough. And then, we have the trouble that the design of the optics is for single sources, but we illuminate them with multiple LEDs. And one effect is, for example, as you can see it here, the appearance of ghost images, as an example here with holograms. Also, this list is not complete, but I think it shows the direction where we're going. And I'd like to summarize this in a few keywords or a few key sentences. So I think our developments at HELLA show that there is a great potential for micro and nano optics for automotive applications. But the main blocker is currently the conflict between the LED and optics characteristics. And I see two ways for further developments. The first one is the improvement of design approaches so that we can optimize the micro and nano optics better for LED illumination. And the other way is the optimization of the light sources for the design approaches. So we have the trend that LEDs are getting smaller and smaller. And with that, of course, we have again more ideal emission characteristics, and we can then again use the current LED design approaches with the LEDs. And yeah, I'm not sure which way is the fastest one, but I see these two ways as the great chances that we have to bring the micro and nano optics to a widespread use. And with this, I'd like to end my presentation, and I stop sharing the screen to see you again and to discuss with you about these statements here.